Alright, students, this is complex number operation examples where we're going to solve some problems. Just as a reminder, the three formulas that we looked at last time was the product rule for complex numbers in polar form, the quotient rule, and the power rule for complex numbers, where if you have a number in the r cis theta form, those two numbers being multiplied together, you take the magnitudes, multiply them together, and take the angles and add them. If you are dividing two complex numbers in polar form, you simply divide the magnitudes and subtract the angles. You have the top angle minus the bottom angle. And if you have a complex number in polar form raised to a power, you just take that magnitude raised to the power and then take that exponent and multiply it by the angle. So let's go ahead and look at some examples here. In this particular problem, we have z1 equal to 8 times cosine pi over 8 plus I sine pi over 8. So this is our magnitude, and that's our theta. We have z2 equal to 2 times cosine 2 pi over 7 plus I sine 2 pi over 7. So 2 is our magnitude, and 2 pi over 7 is our theta. Then they ask us to find the following, which are these things down here, and write your answers in trig form. Give exact values in your answer, not decimal approximations. So the first part here is z1 times z2, and recalling that formula, then the magnitude is just going to be the product of the magnitudes. So 8 times 2, which is 16. And the angle is going to be the sum of the angles. So pi over 8 plus 2 pi over 7. And if you recall the way that we add fractions that have pi in them, the easiest way is just to factor out that pi. So we have 1/8 plus 2/7. Fraction math will give you 23 over 16. So our final answer, 23 over 56. So final answer here, 23 pi over 56 for our angle. Looking at the division, remembering our formula, the magnitude is just going to be the quotient of those two magnitudes. So 8 over 2 is going to give us 4. And the angle is going to be the difference between these two angles. So pi over 8 minus 2 pi over 7. We'll do the same thing as before, factor out the pi. And fraction math, 1/8 minus 2/7 gives us negative 9 over 56. So we'll plug in negative 9 pi over 56 for our answer there. So our next problem says use De Moivre's theorem to find the answer to this expression. Once again, write your answer in trig form. Now you can see here that we have an r cis theta situation of complex number in polar form. So 5 is our magnitude, and 4 pi over 7 is our theta. And we have it raised to the third power. So using that power theorem that we saw, or power formula, it's going to be equal to r to the n cis theta times n. So 5 cubed cis 4 pi over 7 times 3. So that's final answer will be 125 cis 12 pi over 7. And that's it. That's all we have to do. That's looking pretty good. Last problem we're going to look at is using De Moivre's theorem, dealing with the power of a complex number. Unfortunately, though, this complex number is not in polar form. It's in rectangular form. So we're going to have to do a little bit of conversion to polar form so we can apply that theorem. And of course that needs to be in radians. So we'll do just a quick little picture here. -4 along the real axis, -4 on the imaginary axis. We know that's going to put us in the third quadrant. And theta ref there, since we know that this is a right angle with two legs the same, this is an isosceles right triangle. And so the hypotenuse here is going to be 4√2. Based off our recollection of the 45, 45, 90 triangle is x, x, and x√2 for the hypotenuse. So that means that this length would be 4√2. If we're looking for that actual angle theta, we know that would be 180 plus 45, or we can look at the unit circle and realize that the third quadrant angle is 5 pi over 4. So we have 4√2 cis 5 pi over 4 raised to the fifth power. So that's going to be 4√2 to the fifth cis 5 pi over 4 times 5 using de Moivre's theorem. So just a little bit of algebra simplification here. 4 root 2 to the 5th would be 4 root 2 squared times 4 root 2 squared. That would take care of the first 4 powers, and then times 4 root 2. So 4 root 2 squared is going to be 16 times 2. Then we'll have another 16 times 2, and then times 4 root 2. So multiplying all those numbers out, we get 4096 root 2. And then cis, when we multiply these terms right here, we get 25 pi over 4. Now, unfortunately, they want our answer in standard form, which is rectangular form. So we're going to need to expand this back out. Maybe we'll try to fit it over here. I don't know if this is going to work, but we'll give it a shot. So 4096 root 2 cosine 25 pi over 4 plus I sine 25 pi over 4. And so that would be, if we just evaluate cosine 25 pi over 4, we get 0.707, which we recall that's equal to root 2 over 2. If we do sine of 25 pi over 4, type in the calculator, you get 0.77, which you know is root 2 over 2. It's kind of a back way of doing it, but that's okay. So we've replaced this whole entire cosine term with root 2 over 2, replace the entire sine term here with root 2 over 2. I'm going to carry this over to another page, so grabbing this right here. So here we go. 4096 root 2 times root 2 over 2 plus I root 2 over 2. And we'll distribute this whole term to each one of those. So we have 4096 root 2 times root 2 over 2 plus I sine 4096 root 2 times root 2 over 2. Root 2 times root 2 is 2, and then the 2 in the numerator and denominator cancel. So we end up just with a nice friendly 4096 plus I. Same thing over here. Root 2 times root 2 is 2, and then that 2 in the numerator and denominator cancel, and we end up with just 4096 I over there on the right hand side. Alright, so that's some examples of complex numbers and their operations. Hope you had fun. Thanks for watching.